Very good day. So here in this particular chapter, we will be looking further into the general interface of Geomagic Control X Essentials. We'll be learning on how to import bodies and various other features with respect to the general interface of Geomagic Control X. So here I have an open interface of Geomagic Control X Essentials. The interface, as you can see, it looks very similar to a CAD package. So on the right hand side here, where you see my cursor, we have the model tree, and the whole software is organized in tabs. So we have the Home tab, which is a collection of the frequently used tools. We have a CAD tab, where we have limited CAD editing tools. A Measure tab to process point cloud data and scan data if needed. An Alignments tab, a Comparison tab, a Dimensions tab, and so on. So each particular tab present in Geomagic Control X Essentials has its own set of functions added in this particular format. So over here we have our model tree. So we have the reference data, measure data, construction geometries, etc. So whatever you import would be imported directly into this particular interface. And in order to import, you can go ahead and say import over here. This particular button will let you import your particular file. So you can navigate to your folder of interest. For the purpose of this particular training, please use the files that are provided to yourself. So here I can go inside this particular file, and you can see that there's a CAD file in the step format and a scan file in the STL format. So you can select a CAD file directly and import it as it is. So we can see that the CAD file is imported here, and it is added under the reference data section present in this particular model tree. So right away the file gets imported and it's added to the reference data section. In Control X we support all the different types of CAD and scan file formats. And coming to the interface controls, you can scroll your wheel in the mouse, so you can move the scroll wheel in and out. So scroll wheel in and scroll wheel out will zoom in and out. So again, explaining, scroll wheel on one direction pulling towards you will zoom out, and scroll wheel away from you would zoom in. So you can practice this a bit. And following the zooming in and out, in order to rotate the model, you can click and hold the right mouse button, and whilst you have the mouse held, you can move your mouse. Rotation icon would also be placed on the screen. So this is how you can rotate a particular body about its view. You can hold and rotate in any particular direction as per your requirement. So in order to rotate a particular body, you can click and hold the right mouse button, and while you have the mouse held, you can move your mouse. This is how you can rotate a particular body. And in order to do a pan action, it's also quite simple. You can click and hold your right mouse button. Now click your left mouse button and hold it. And when both of them are held, you will see that you have the pan icon come up in white, and you move your mouse towards the left or right in whichever direction you want to move. So this is how you can pan your particular body. So coming again, it's click and hold the right mouse button and then click and hold the left mouse button. And when you have both of them pressed together, you can move your mouse in order to pan this object across the different directions. Now, it's a bit hidden, but you have a menu in the area where you can see my cursor. So when you make a click on it, it is going to expand this particular menu. And here you would be able to see what each of the mouse controls mean. What is the rotate icon mean? It means click and hold your right mouse button and move your mouse. Pan is click both of them together and move your mouse. Set a rotation point is your middle mouse button. And a pop-up menu can be obtained by making a right mouse button. So you can expand and collapse this mouse controls as needed. So during the time you're initially practicing, it might be essential. And in Control X, on the top, very top, we have a setting called Preferences. If you can see where my cursor is, it's a small folder icon with a settings wheel. So you can click on that in order to open the Preferences settings box. So here you have quite a lot of settings that you can turn on and off according to your interest. So coming to the important ones, there's an item here called data save. If the default is set to false, you can set it to true so that if and when the software crashes, for every X minutes, which you can set it here. I've set mine to 30, but you can set it to 10 or 60 as per your convenience. So here I have my automatic recovery saved in true, and I have set the recovery time to 30 minutes, which means for every 30 minutes, the software will automatically save a recovery copy of the file with which I'm working. You have an enable automatic save reminder. I have set it to true, and I've set it to 60 minutes so that at the end of every 60 minutes, the software would ask me if I want to save it or not. Now, coming to the mouse controls, we saw the default mouse controls in Geomagic. However, if you are familiar with other mouse interfaces like SolidWorks, NX, Creo, CATIA, you can select the apt mouse controls and set it. I am going to go ahead with default, but if you're familiar using a CAD package, like any of the packages that are shown here, you can set it accordingly and use it. And here in the zooming center for the mouse wheel, if you have it on screen position, I would advise to change it to mouse position. So when you have it on screen center, whenever you move your scroll wheel, it will zoom in and out with respect to the center of the coordinate system. However, if you have it in mouse position, it's more comfortable. It would zoom in wherever it would zoom in and out wherever you are pointing your cursor. And here we have the default input scanner units. This is the units within which you want to import your scan. And below here we have your default measurement units. So if you're somebody who works with inches in your company, you can change it to inches or feet appropriately. I am going to keep it in millimeters for the purpose of this lesson. And we have a few other items here that are not as important, but you can change it to your interest. And once all of this is performed, you can click on apply and you can click on OK for these changes to take place. Now, within Control X, whenever you import a CAD file, the software will automatically determine the type of surface when you hover your mouse on top of it. For example, when I hover my mouse here, it says it's a cylinder. It says this is a cylinder. It says this portion is a cone. When I hover over it, automatically the software is equipped with feature recognition capabilities that will tell you what type of a feature it is. And in order to understand further details, you can always click on the particular CAD file from the model tree. And if you go to properties, it would tell you some details. So here it tells the name of this particular file is cat. It's a solid body. This is the color applied to this cat. Its bounding box dimensions are 125 by 125 by 75.1. And if you want to calculate details like center of mass, you can hit calculate here, and the software will automatically provide you with the X, Y, and Z positions of the center of mass. Likewise, to select a particular item, you can click on it, and when you click on it, the object would turn in a turquoise color. It would be highlighted in a turquoise color. And for any item that is clicked and selected, you can go to properties, and it would automatically tell you what the name of the entity is. So we selected a face, so it says the entity type is a face. If you want to calculate the area, you can say calculate, and it would perform the calculation for you. And it also shows some other further details which we'll be looking into shortly, like the fitting type. We have best fit here, but you can change it to max inscribed, minimum circumscribed, etc. Now, the same way we had imported the CAD file, you can also go ahead and import the scan file. So you can say import, and you can choose your STL file. And here, there are some items that need to be taken note of. So we have an option here called Use Custom Setting. So in the Use Custom Settings, it's advisable to keep it checked on. And if you want to import this body as a point cloud, you can check points only on. If that is not the case, you can uncheck it. And here I have the units set to millimeters, but this is the units in which the body was scanned. So if the body was scanned in inches, you have to import it in inches. If it's in millimeters, you can select millimeters and say import only. So here right away we see that our scan has also been imported. So you can zoom in and out. And in order to hide the CAD file, you can toggle it on and off. So you see where my cursor is. I'm having it directly to the right of where I have the CAD in my model tree. And I can toggle it on and off to hide and then to show my CAD file. The same method applies for any object. So here for my scan, I can click hide, like I can have it toggle off to hide, and I can toggle on to show. So you can practice this a few times, how to hide and show objects accordingly. So here as well, I have my particular scan file imported. And on the top here, we have our visualization and selection icons. So here I have a few ways to see my rendering. So the first option that you see here is point set. So I can click on point set, and now when I zoom in, I can see that my rendering is performed in a point cloud style, even though the body was a mesh. The second option likewise is a transparent wireframe. You can see that the body would show the triangles, but it would not shade the edges. This third particular method of rendering is called shaded without edges. This is going to be the most commonly used rendering method, in which the triangles are shaded but the edges are not displayed. And after that, we have shaded with edges, where you also add the triangle edges along with the element faces. And the same things apply here. So if you click on part 1 and go to properties, you can see that this name is part 1. The type of this body is a mesh. Here it would also show the bounding box dimensions of this mesh. So what's the width, height, and depth of a bounding box of this mesh. And here it also displays you the total number of triangles, which is 1.918 million. And for vertices, we have 960,663 points. And you can also compute the center of mass the same way you computed it by clicking the calc button. So the properties would display whatever information you have about a part that is selected. Now, coming slightly to the left, here we have our visualization views. So we have our front view, back view, left view, etc. So you can click on any of these buttons. So if I click on front view here, you can see that the plane of visualization automatically adjusts to the front view. I have the back view here, and we have the left side view, the right side view, and so on. And whenever you hover your mouse over a particular command, if you have something in brackets, so here it says front view in brackets Alt plus 1, it means that it is a shortcut. So if I go here, it is going to be Alt plus 5. The next one is Alt plus 4, 3, 2, 1, and so on. So you can also have Alt 1, Alt 2, Alt 3, Alt 4, Alt 5, Alt 6, and Alt 7 to view your body in your standard views. So these are your shortcuts. And besides this, here you have rotate the model in a 90 degrees clockwise direction. And here you can click to rotate the body in a 90 degrees counterclockwise direction. So this one is clockwise. To the left, you have counterclockwise. And to the side of this particular button, you have your flip viewpoint. So this is going to change the direction 180 degrees. That is, it's going to flip it to the back side. So if I click here, it's going to flip my viewpoint 180 degrees. That's what this flip viewpoint tool does. Now, towards the side of this particular body, towards the side of this particular interface, we have our selection icons. So here, currently I have my scans shown and I have hidden my CAD. So you can also select a part of the scan by making a drag box if needed, or you could go to the measure tab and say, make a drag box for me. Now, whatever area is highlighted, it is shown in a turquoise color. So here you have a line selection mode in which you can click and hold your right mouse button and move it to the right. Very simple. This is done to select polygons across a straight line. So you can click on a particular location, hold the left mouse button, and drop at another location. This is going to select triangles across a line like that. Click, hold, and move. Now, the same applies for this particular selection. It's called the rectangular selection mode, where you kind of make a drag box and select your polygons appropriately. So you can notice that since you had a hole here, it also selected some triangles out on the other side. So in order to remove triangles that you don't want, you can hold Control on your keyboard and make a drag box again, like that. So this ensures that you have not selected that particular area. You can remove it further. For example, I can click and hold Control and make a drag box to remove these much triangles from my initial selection. Now, you can always right click and say none, or you can say escape on your keyboard or click elsewhere to remove a selection. So coming to the basics, if I'm on line selection mode, I can click and move my mouse to get a selection. Click, hold, and move your mouse. To add to my selection, you can hold Shift and add as many polygons as needed. This way. The same method applies for the drag box method. You can select an area here. If you want to add to a selection, you can hold shift on your keyboard. Hold shift on your keyboard and make your selections. This is how you add polygons to your selection. And to remove polygons from your selection, you can hold Control on your keyboard and make your drag box selection again. So I can make a drag box around this whole item and remove from my selection. Likewise, we also have a few other selection tools here. So we have this tool at the very end called Smart Select. This is a curvature sensitivity based tool. So you can click, hold, and increase your selection. So you can click and hold the left mouse button. It would select a few polygons. Now you can move your mouse in either direction. In one direction, it would increase the selection, and if you move it in the other direction, it would reduce the selection. So I'm reducing it now. Now I'm going to increase my selection. And even for generic amounts of selections, you can see the properties. It would say it's a polyphase. You can click calculate and you can extract the area and other details this way. And as I mentioned previously, to remove all selections, you can say escape or click elsewhere on the screen. So these are your visualization and selection icons. So we have imported our CAD file and our scan file. Now, right away, we can see that the CAD is imported and the scan is imported, but they are not really dialed up with respect to each other. So we have a whole tab dedicated to performing alignments. As we saw in the last video, metrology is essentially a comparison process between the CAD data, your ideal blueprint, and your scan data. So here we have an alignments tab, and we have our initial alignment, best fit alignment, 3-to-1 alignment, and many different tools. So to start with, you can click on initial alignment. This tool is very simple and easy to use. It only has two options, either a quick option or a precise option. The main task of the initial alignment tool is to bring the scan data as close as possible to the CAD data. So if you select quick, the software in the background will select a limited number of points on the scan, and it would try to match it and move it and align it to the CAD file. So whenever you click any tool here, it will pop up a widget, and you can give the check mark and say OK. So when I give the check mark, it's going to add an initial alignment object here. So it adds a new object called initial alignment 1 in the alignments tab. So I'm going to say OK here. So when I say OK, the software will run its algorithm, and it will immediately, with a single click, place the scan file on top of the CAD file, like that. So now we can see that we are in a lot closer position to make our comparison. We brought in our CAD file, we brought in the scan file, and we performed an initial alignment. And you can find the initial alignment that you performed in the model tree here. It says initial alignment 1. And you can also take a look at the properties shown in the right hand side. And if you want to remove this initial alignment, you can right click and say delete. Now this is going to remove this particular initial alignment. When I say yes, it's going to remove it from the model tree, and you go back to your initial position. So that's how easily we can do alignments. So click on initial alignment. You can choose quick or precise. Precise is a slightly more accurate model, but we can start here with quick, and you can say OK. And right away, the software with a single click will align this particular file with respect to the CAD file. Now, Once the initial alignment has been performed, you can refine this particular type of alignment in a few different ways. So in order to do that, we have the best fit alignment method, we have 3-to-1 alignment, we also have datum alignment method. So in most of the cases, uh, a lot of the companies form or use the datum alignment method. So you can find them to the side in the second bin. So here you have your best fit, your 3-to-1, and your datum alignment method. And one of the good things about Control X is that when you hover your mouse over a particular tool, the software automatically tells you what the tool does in a short format. For example, here it says it aligns the measured data to the CAD data by matching geometric features. So you can click on datum alignment. Now, whenever you click on a particular tool in Control X, you would get a widget towards the left side, as you can see here. And if you click F1 on your keyboard, you will be able to notice that the software automatically takes you to the help documentation. So here in the model view, I have datum alignment, and when I clicked F1, it took me to the help documentation of my datum alignment. And here it would explain you in detail what this particular tool does and what each different bullet present in the particular option performs. Like here, it would tell you what its benefits are, how to use this tool, etc. It's a very detailed and in-depth documentation. So after you have performed your initial alignment, you can select your datum faces. Say, for example, I can select my primary datum face as this one, and I can select my secondary datum face as the cylinder. And with each passing selection, you'll see that the software refines this alignment by matching these two faces perfectly. Then you can make another click here and say, for example, you choose this as your third datum face. Now here you can say OK, and the software will automatically make the datum alignments, and in your model management tab it will add it as datum alignment 1. So here this is your datum alignment 1. So you can start with an initial alignment. In the initial alignment, you bring the scan close to the CAD as much as possible. After that, you can refine that alignment further by means of a datum alignment. Now, we do have another type of alignment called best fit alignment. This type of an alignment works very well when we have a lot of flat faces, cylindrical faces, machined faces, etc. For more complex bodies, you can also use the best fit alignment. The best fit alignment is a more iterative form of alignment. So here you can provide a sampling ratio on how much percentage of the points in the scan data you want to use for alignment. So I have given it at 100%, and you give an iteration count, say 20 or 40 or some number like that, and a maximum average deviation. And if you don't know it, you can click on estimate. So this is a more iterative process by which the software will apply small movements to the scan data, and it will try to move the scan data, compute the maximum average deviation, and it will attempt to bring it below this particular value that you have specified. So this is also an iterative process. It's called best fit alignment, and it works very well with data when you don't have a lot of uh, flat flat faces or cylindrical faces that you can choose as datums. So this is datum and best fit alignment. And each alignment that you make would be added in your model tree in the alignments bar. So here you have a particular area designated for alignments, and you have initial alignment, the datum alignment, and the best fit alignment that you had performed. This is how you can import CAD. You can import a scan and perform the alignments with respect to each other. Now that we have imported the CAD and scan and aligned them properly, we can go ahead and perform some initial holistic comparisons. So here we have a whole tab dedicated to performing comparisons. So the first option is the 3D compare. So this tool essentially provides you with a heat map. So when you click on 3D compare, you get this particular widget. You can choose a sampling ratio for how many points you want the comparison to be used on. And you have a radio button for the method. You can select shape. Thickness is for comparing the thickness. It's more useful for cases like blades. So you can click on shape here, and you can also choose the projection direction as required. You can either choose the shortest option or the along normal, or if you want to do it along a custom direction, you can choose that. So here I'm going with the shortest distance from the CAD, and we also have a max deviation cutoff that you can give. Say, for example, if you want to plot all the deviating points, but not points that are deviating more than 5 mm, there could be some outlier points or some noise. So you can add that particular value here. And if you're unsure, you can always click and select auto. And then you can go to the next stage. Now here, right away, you would be able to notice that the software has made a color map, and you can rotate across this particular color map and see how the patterns vary. So basically, you would also see a scale on the right hand side, and you have a max and min range. So the default, or the one that I currently have in my screen, is set to plus or minus 1 millimeter. So you can change that. You can add it to, let us say, plus or minus 0.75 millimeter, and the heat map would change its color based on the scale that you see here. So anything you see varying from a 0 in a positive direction, it would have a yellowish to a reddish coloration, and anything that you see in a bluish coloration will have a negative deviation from 0 to negative 0.75. And you can always hover your mouse on a particular area, and the software will display the deviation in that point. So here it says negative 0.75. If I move it more towards an area that's yellow, here it says it's plus or minus 0.075. You can click and hover over to see the deviations occurring at these particular points. And you can also set a band of specific tolerance. So if you're fine with a measurement, say plus or minus 0.05, anything within plus or minus 0.05 would be shaded in a green color. So in this particular chart, anything that you see in green, say an area like this, it would be within plus or minus 0.05 millimeter of the CAD. So you can choose these scales comfortably as per your interest. So I can choose, like, let's say plus or minus 1.25 mm. I can add a specific tolerance of plus or minus 0.1 mm, and I can see across the model. I can rotate and check and see where I have more CAD and where I have less, where I have more material and where I have less material. Say, for example, we have this particular area where it's yellow, which suggests that the CAD is above the scan, and you can see the same particular item behavior described here as well. And below this particular button, you also have local average tagging. So you can choose a particular number of points. So here I have an over tolerance count and an under tolerance count. If I want to see the top two worst deviating points in each direction, the software will automatically print it for you. So it's negative 0.967 mm in the negative direction and positive 0.9604 in the positive direction. So I've added 2 here. You can also add 1 if you want to just see the worst deviating points. So in the background, the software will project the points on the scan data onto the CAD and compute the deviations between the CAD and the scan. You can also click on individual points. So you can click on a point, say like that, to find out the deviation between the CAD and the scan across that point. Say for example, you have this orange colored zone. You can click on that particular point. I can click on this point here, and I can click on as many points as I want and plot the deviations between the CAD and the scan. And you can say OK here, and once you say OK, a 3D compare object would be added in the model tree. So here I have a 3D compare object, and if I expand it, I have all my comparison tags. So these ones as well you can hide and show as per your interest. So here I have my 3D comparison with all the tags hidden, and you can show it anytime you please, like that. This type of a comparison ensures that you can see where you have more and less material across the whole model. And you can also drag and place these annotations as needed. So you can click on them, hold them, and move them this way. So I'm kind of placing them and spreading them apart like that. And I can say OK. Now, if you want to hide this 3D comparison altogether, you can see that inside this analysis box, you have 3D compare here. So if you click hide here, it would hide all the colors. It would not show that particular analysis object. So this is how you can show and you can hide your 3D comparisons. Now, this type of a tool can also be used to just model one particular section. So you can add another 3D compare here, and now instead of adding it on the whole body, if you're interested just in this particular face, you can say selected data, use selected data only. You can click that particular option and select the particular face of interest. Now you can go and say go to next stage, and you can add your maximum and minimum ranges of interest. Say for example, if you wanted to do a more lesser bandwidth, you can say plus or minus 0.75. And for the specific tolerance, you want to tighten it further, you can say plus minus 0.05. And if you want to find the worst deviating points in each direction, you can give a 1 and a 1 here. If you want to find the top two worst deviating points, you can give 2 over there. And there are some ways you can pick with respect to patterns that we'll look into later. But once you have it here, you can also mark the deviations by clicking on the points as necessary. So here you can see I'm adding one for this yellow zone. I'm adding another deviation marker for this yellow zone. So this way you can make a 3D comparison on a particular face of interest, and you can mark these annotations accordingly so that you can know what each of these colors signify. Oftentimes, although you have the color scale to the right, the presence of a of an annotation here would help it would help to associate a color zone with a numerical value. So here I can have this deep orange color as 0.21 mm, this light yellow color is 0.09 mm, and here this green zone is a very close fitting 0.034 mm, and so on. So this is 3D comparisons and how you can import a CAD file, align it, and extract a heat map to display the deviations right away. And you can hide this particular 3D compare as well by toggling this on and off like that. And in our first case, we saw that we made a 3D compare like this. Similar to a 3D compare, we do have another option called the 2D compare. So you can click on a particular section, a two-dimensional section, and cut across the section to identify the variations between the CAD and the scan across a particular section. So here, for example, I can click on 2D compare, and the software would open up this widget. It would ask you for a base plane. You can either make a base plane of interest, or you can select a plane from the particular CAD file. So I can select a plane like that, and the software asks for an offset. So you can click and hold this blue arrow and bring it down. So here I've brought it down by -2.5 millimeters. However, if I wanted just 2 mm, I can always edit this particular value by typing in 2 mm here, where it says offset distance. And like in the case of the 3D compare, you have 3 bullets here: shortest, along, normal, custom, and you can go to the next stage. Now, when you click on next stage, the software right away would display a whisker plot. So here, if you zoom in, you would be able to see a thick black line which is actually a section of the CAD, and this squiggly line that you see here in color, it's a section of the scan. And if needed, you can increase the scale by moving the whisker multiplier here. This provides you with a much better or a much more exaggerated view like that. And you can click across the points of interest to find the deviation between the CAD and the scan. So I can click in this green zone, and I would be able to make my deviations there. I can click in this particular point, and the software would show the deviations between the section of the CAD and the section of the scan across the plane that you had selected. So this is how you can make a two-dimensional comparison between a CAD file and a scan file across a plane. And once you say OK, it would be added in this particular body called 2D compare, which you can hide and show as well. So for the purpose of this lecture, we saw some of the basics regarding the interfaces of Geomagic Control X Essentials. We also saw how we can import our CAD files and our scan files and how we can align them together. We learned about initial alignment, best fit alignment, and datum alignment schemas. And we also saw how we can extract a 3D comparison heat map where you can see a color plot across the different points on the scan. We also saw how we can apply it to a local face or an area of interest. And we also saw how we can select a particular plane and cut it out together to make a 2D comparison in the form of a whisker plot. So these are some of the holistic comparison tools that you can use prior to performing other detailed comparisons within Geomagic Control X. I hope this lecture was useful for you. We will look into the further capabilities of the software in the next session. Thank you.